steps in solving problems involving inequality. So first, we're going to read and understand the problem. Second, identify the given conditions and the unknown. Third, represent the unknown using variable. Fourth, devise an equation or inequality that corresponds to the given conditions and the unknown in the problem. 5, solve for the unknown. And 6, check your answer. All right, let's start answering our first uh, problem. Our problem here is an amusement park wants to place a new rectangular billboard to inform visitors of their new attractions. Suppose the length of the billboard to be placed is 4 meters longer than its width and the area is less than 96 square meters. What will be the possible dimensions of the billboard? Now, we're done with the step 1 in reading and understanding the problem. Let's go with number 2, identify the given conditions and the unknown. The given conditions here is the length of the billboard, which is 4 meters longer than its width. And we also have here the area is less than 96 square meters. And we are asked to look for the possible dimensions. So it means there are many possible dimensions for this kind of problem. So next, step 3, represent the unknown using variable. So we're going to represent, since here the length is given as 4 meters longer than its width, so we're going to represent first the width. So let x be the width. Next, given that the length is 4 meters longer than its width, so translating 4 meters longer than its width, it will give us x plus 4. X plus 4 be the length. Now, let's go with step 4. Devise an equation or inequality that corresponds to the given conditions and the unknown in the problem. So, we have here the condition area is less than 96 square meter. So, it means area is less than 96 square meters. And we all know that the billboard is a rectangle since the given dimensions are length and width. So, we're going to change A to length times width as the area of a rectangle is equal to length times width, less than 96. Now, we're going to substitute our variable x for the width. So, x will be here and then the length is x plus 4. So, L will change that to x plus 4. The width becomes x less than 96. Oops, there we go. Next, we're going to apply a distributive property. X times x will give me x squared. Second term, 4 times x will give me 4x. It's less than 96. Now, let's transform this into standard form. X squared plus 4x minus 96 is less than 0. Alright, so now we have obtained our equation. Since we have now our equation, let's solve for the critical points or the roots. So first, let's copy that one again here. X squared plus 4x minus 96 is less than 0. But again, the first step in solving quadratic inequality is to replace this inequality to equal sign. So x squared plus 4x minus 96 is equal to 0. Now, since we're always using factoring, allow me to use a different method. I'm going to use completing the square. Now, completing the square is appropriate if you see the value of b is an even number. It will be easier for you to use this completing the square. Like for example, let's the first step here is to isolate all of the terms with variable x. So x squared plus 4x is equal to 96. Now, let's put some blank here. So again, you need to isolate the terms with x on the left side and then the constant term on the right side. Next step, we need to identify the number that should be put here on our blank. And that number should form a perfect square trinomial on the left side of the equation. And to identify that, we're going to use our formula b over 2 squared. And again, this is just for our sketch, and I'll remove this later. So our b here is 4. So substitute 4 on b, 4 over 2 squared. And then this will give me equals 2 squared, or this equals to 4. So this is going to be plus 4, and then add also 4 on the right side. Again, if you're going to add a number on the left side, it should be also added on the right side. Now, let's transform this perfect square trinomial to a square root binomial. So that is equivalent to x plus 2 squared, or the square root of x plus 2 equals 96 plus 4 will give me 100. All right. Now, we're going to apply square root property. So, to remove this square root both sides. So, this will give me x plus 2 equals. So, again, we're going to have two values for square root of 100. That is positive, negative 10. That's going to be positive, negative 10. Then, let's solve for x. So this is going to be x equals plus minus 10 minus 2 by APE, of course. And then separate the two equation. We're going to have here two equation. The first equation is for the positive 10. So x equals 10 minus 2. Then the other one is x equals negative 10 minus 2. So x here becomes x equals 8. And then the other is x equals negative 12. So let's plot these points on our number line. So allow me to create a number line here. Okay, let us now plot our critical points, which is negative 12 and 8 on our number line. So suppose this is negative 12 and then this is positive 8. And remember that our inequality here is less than, so we're going to use an open circle. Next, let us now identify our intervals. For the first interval, we have here x is less than negative 12. And then the middle interval, we're going to have x is greater than negative 12, but less than positive 8. And for the last interval, which is x greater than 8. Now, after getting the interval, we're going to solve our test point. So for the first test point, let us first start with x is less than negative 12. Test a number that is easier to solve. So I think I'll be using the next number here, or which is negative 13. So test point here is negative 13. So I'm going to try the test point negative 13. Then copy our inequality, x squared plus 4x minus 96 is less than 0. So substituting negative 13 squared plus 4 times 13 minus 96 is less than 0. And then this is going to be 169. Oh yeah, forget this negative 13. This is negative 52 minus 96 less than 0. Combining the numbers, we're going to have here 21 is less than 0. Now the statement is, of course, false. Since this is false, we're not going to draw any line on our number line. So let's proceed with our next interval, which is x greater than negative 12, but less than 8. So I think you need to think of a number that is the most easiest between these numbers. And I think I'll be using 0 for this one. Allow me to erase this one. Let's change our test point to 0. Let us now substitute our test point 0 on our inequality. So 0 squared plus 4 times 0 minus 96 less than 0. And of course, this is going to be 0. This is also 0. So what's left is negative 96 less than 0. Now, this statement is true. Since this is true, we're going to draw a line on our number line. So connecting the two. So there you go. Now we have our line. So next, for the last interval, we're going to check for x is greater than 8. Now you can think again, the most easiest number that you can think of that is greater than 8. And I think we're going to use 10. Since 10 can easily be solved, right? So next, again, erase this one. And let's do the substitution. So 10 squared plus 4 times 10 minus 96 is less than 0. That's going to be 100 plus 40 minus 96 is less than 0. So combining the numbers, we're going to have here 44 is less than 0. Is this true or false? Of course, this is false. So no need to draw a line. So allow me to erase this one again so we can have some spaces. Since we have our interval here, x is greater than negative 12 but less than 8, so the measure of our width will be located here. And of course, speaking of measurement, we're going to use just positive values, and of course we'll just also ignore 0 since there's no 0 for a width. So we'll start with 1. So for the width, we're going to have here 1, 2, 3, 4, 5, 6, and 7. Of course, because the values or the width should be less than 8. So if our width are as follows, then our length, so according to our statement, the length is x plus 4. So we need to add 4 on each width. So 1 plus 4 is 5, 2 plus 4 is 6, 3 plus 4 is 7, 4 plus 4 is 8, 5 plus 4 is 9, 6 plus 4 is 10, 7 plus 4 is 11. And of course, since we're dealing with measurement, don't forget the unit of measure, which is meters. All right. And also, since when it comes to dimension, we start first with the length before the width. We're going to have here 5 meters by 1 meter, 6 meters by 2 meters, 7 meters by 3 meters, 8 meters by 4 meters, 9 meters by 5 meters, 10 meters by 6 meters, and 11 meters by 7 meters. So these are the possible dimensions for our billboard.